The count min sketch is a probabilistic data structure that tries to keep track of the counts of the elements that we've seen. So it's generally used with an input stream of data that would be too large to completely store in memory. So it's a probabilistic data structure, meaning we don't have exact numbers. We have some probabilistic range of accuracy. It's memory efficient, so it actually is constant space with respect to the values that you choose. It doesn't matter, like once you create it, it doesn't grow in memory whatsoever, no matter how many elements you've seen. And it provides an upper bound on the counts of elements that you have seen so far. So much like a Bloom filter, we must define multiple different hash functions, which is k. I'm going to say k is the number of hash functions. In this case, I have 3 hash functions. And each hash function corresponds to one row in the Bloom filter, which is a 2D array with k rows, one row for each hash function, and some m number of columns. So each hash function corresponds to a single row. And an initial count min sketch, it's initialized with every single count as 0. So these values are going to store our estimates of counts. So how do we actually use the count min sketch? When we see the first element, for example, b, let's say I want to increment the count of b. For each of your hash functions, you will compute the corresponding hash value of the element that you've seen, mod that by m, the number of columns, and increment the corresponding count in that row for that hash function. So for example, h1 of x is just the ASCII value of x. ASCII value of b is 66, so h1 of b is 66. I mod that by the number of columns in my count min sketch, which is 5. So 66 mod 5 is 1. I go to the h1 row, and I increment the count at that index. So this count is now 1. I do that for every single one of my hash functions. So still on the same insertion, I've still only seen 1b. I finished the increment with respect to the first hash function. Now I do the second one. 2 plus 66 is 68. Mod 5 is 3. So I go to the hash function 2 row, increment the count at index 3. Do the same thing for this one. 66 times 4 is, so 66 times 4 mod 5 is 4. Right? 6 times 4 is 24, so then whatever it is, mod 5 is going to be 4. So I'll go to the row corresponding to the third hash function, go to index 4, and increment that as well. So a count min sketch, basically to find the count, or at least an estimate of the count of any given element, what I would do is, so that was to increment it. So to increment, I compute each of these hash functions, mod by the number of columns, and then for each of the hash functions, go to the corresponding index of that row and increment the count. To try to retrieve the count of a given element, what you would do is also compute all of your k hash values, go to the corresponding elements in their respective rows, and the minimum of the k values that you see, the minimum of those k counts, that is an upper bound on your true count. So if I tried to find the count of b, I would compute those same 3 hash values, go to those same 3 indices. The counts are 1, 1, and 1. The minimum of these 3 values, which is 1, gives me an upper bound on the count of b. So I've seen b at most once. Let's see what happens if I try to find the count of a. So a, the ASCII value is 65. 65 mod 5 is 0. So I go to h1's row. the count is 0. So one option is 0. 65 plus 2 mod 5 is 2. So the next count is also 0. 65 times 4 mod 5 is 0. So my three counts are 0, 0, and 0. The minimum of these three is 0. I've seen A at most 0 times. Let's try one more example. Let's try finding the count of G. So 71 mod 5 is 1. So H1's row index 1 has a count of 1. 71 plus 2, so 73 mod 5. The index, so that equals 3. So I go to index 3 of the row corresponding to H2. I also have a count of 1. 71 times 4 mod 5 is 4. So in the H3 row, I go to index 4. I see a count of 1. So my counts are 1, 1, and 1. I take the minimum of these three values, which is 1. In these examples that I'm doing, they all ended up being the same, but these numbers could hypothetically be different. But regardless, take the minimum of whatever k values you see. So the minimum of these three is 1. That is the upper bound on the count of G. So I've seen G at most once. Well, this is true. I have seen G at most once. I've actually seen G 0 times, but this has now screwed up my estimate for G. I am incorrectly thinking that I've seen G potentially more than I actually have. In other words, B and G in this example are completely indistinguishable. So this quick example of a Countman sketch that I've given you, as you can clearly see because I have indistinguishable elements, is not a very good Countman sketch. How can we design an optimal Countman sketch that can give us as close to accurate as possible of an estimate of any given element's count?